Steve Tully. I'm the project manager of the project. This is through Mass Hire from Leominster on Urban Way. It's a group that helps with school to career activities and with career development. So I'd like to thank the parents for being here today, the Turners, thank you very much. I'd like to also thank James Costigan from APAC. This will be shown onto Channel 8. I'd like to thank the faculty for being here as well. If you just want to go around the room, just introduce yourselves real quick.
Bill Moore.
Andy Whitmore. Gary Reynolds. Keisha Newton.
Kayla Kelly.
Bill McKenna.
And parents, the Turners.
Okay, Hayden Turner.
Susan Kennedy.
All right, thank you very much. So Tony Wilson and Kelly French from Mass Hire have been very helpful with this. We started this back in January, having meetings with students, and even before that with the senior class, right before they left to go for the holidays in December. And then from there, we started with our first program date, or a meeting if you want, for the program to start off into February, right before the vacation. And through the vacation, they fill out their paperwork. There's a program for 100 hours. They can get up to 100 hours at $15 an hour. That's $1,500 that they can get. And they've earned a lot of it so far. We've been into week number 16 now of our program. So I'm very proud of how they've been working. They're a great group to work with. We did, if you look at the green sheet, this right here is a fact sheet that we went to present to the faculty back on May the 2nd. And it has a whole bunch of things here that are required in boldface, and also two other items in there as well that go along with the program. One of the big things that we had with this project was that the students had to go to involve some businesses and to be encouraged to work with businesses. So one such business, a local one that we have here in Shirley, All Star Sporting Goods, which you'll see in the video. We broke it down. Students, we have Isabel Viacamosi, she's doing the chemicals and properties of foam. Devin Gibbons, physical properties and design. Miles Pyatt, networking and industry. Ian Powell's computer-aided design and 3D printing. Abigail Turner is doing the health and the ergonomics, and I was the project manager to make sure what we're doing and to keep things on course and so on. They're a great group to work with. It was not hard to do that. They self-motivated and they were energetic about this. So most of our meetings happened on Wednesday afternoons from about 2:30, 2:45 to about 5 o'clock. We still have a little bit more to do because one of our goals is to present the school and Mass Hire and our committee here, the steering committee. So I really appreciate everybody for replying back to make a packet like this, okay? And this right here is from Tewksbury STEM program. They did theirs from Thermo Fisher Scientific. They did a lot of work with them, and they broke it down by week. So eventually we'd like to make something like this here to emulate this program as well in that. Next year, we're starting to work towards having a school to career activity each term. The first term, what we want to do is have a career fair the first term, and then into the second term, go into what's called the reverse college day / trade day, where students from college can come back in the first 2 years of school or 3 years of college, or in their trade if they went right away into that after school with some training, to come back and to share their experiences with the students. So that way juniors and seniors can know what they have to do to improve or keep going along with what they're doing if they want to go to a career or to study into a major of their choice. And then the third term, we want to do a career fair geared towards the seniors that may not have some plans after high school at that point, and then this program as well for the STEM program. So we're going to have 4 different things hopefully next year. That's our goal, and that's why we have our group here at the steering committee. So with that, I just wanted to say that Mr. Yerger from All Star, he gave his words of encouragement to you folks here today, and he wishes you well. That their group is in a process of a move from Shirley to Leominster, right next to North End Diner. They're trying to get a bigger facility. So right near the train tracks, so it's really good for commerce as well, and to get things into Boston and so on. It's an international group, and so they're in the process of a move. So he said, said he couldn't make it today. So anyway, so without further ado, here is the Panther Innovation Project. Move aside, and we all set. I also have the packet here. Feel free to take down the notes. I have points at the end here on the back. If you take a look at it, there's an introduction, anatomy, the phone, all of the parts of the project is broken down, the presentation, and then the rating at the end. For the teachers, I gave you already an observation and evidence tool already, so you can have that when you go to present your evidence next year to administration. We have that taken care of, and when we get into talk about the businesses, I'll chime in there about the NCAA, about what we're trying to do with the foam roller with them through All-Star. So get the students involved here and have fun.
So we first had to obviously brainstorm a topic, or like what we're gonna do for this project. We first had 4 ideas ranging from job fair, magnetic locks for bathrooms in case the locks are ever broken, climate change analysis chamber, so like students would watch how climate change changes an environment in a controlled one, and then a compressible foam roller. We submitted these 2 ideas, or 4 ideas, and only 2 of them passed, the magnetic locks and then the compressible foam roller, and we chose to focus on the compressible foam roller.
So, before we go into the talk about what goes into the idea of a compressible foam roller, we're going to talk about how it affects the body. So if you want to click to the next slide.
Yep.
The kinesiology is basically the study of movement, the inside body, essentially. And biomechanics is the study of how outside effects affect the body. And delayed onset muscle soreness is basically any pain or any soreness that you feel in your muscles after working out, which everyone experiences. So what happens, so delayed onset muscle soreness is also called DOMS, and it's when the muscles or myofascial structures, tissues, which is basically the scaffolding of your body, tear or tighten up, and it makes it really hard for your body to heal after working out all the time. So foam rolling is a form of self-massage. It helps realign muscles and tissues. It also helps reduce injury by realignment of muscles and tissues, improve range of movement, alleviate pain, increases blood flow, and can help with flexibility. And it's highly recommended within concentrated amounts. So you don't want to go doing it every day. You'd want to do it when you're especially sore or before a really intense workout. The pros of foam rolling is it releases muscle stress and relieves pain. Some cons is overuse, and if you're pregnant, it can actually induce labor if you foam roll specifically your calves. So yeah, just be careful of the symptoms, which can be if the pain doesn't go away in 7 days, and your urine is abnormally dark and you have extreme swelling, you want to go to a doctor or a medical professional. So there was an experiment done by the Memorial University of Newfoundland, the School of Human Kinetics and Recreation, and they said, okay, so what does foam rolling actually do and how does it affect the body? So for 30-meter sprint times, there was an increase of times without foam rolling at roughly 97%, with a 0.06 second increase with foam rolling, as opposed to a 0.17 increase in times without foam rolling. For broad jump distance, there was a decrease in centimeters without foam rolling, and that's at roughly 99%, with a 5 centimeter difference with foam rolling, as opposed to a 15 centimeter difference without, And the change in direction speed also changed with an increase of roughly 75%, with 0.23 seconds with change without, as opposed to a no change with foam rolling.
Of course, when we talk about foam rolling, we have to talk about the foam that goes on the roller. So to start off my research, I need to know what the heck is foam. So I came up with my own personal definition with the help of Google, obviously. Foam are materials that are formed by trapping pockets of gas in a liquid or solid. So obviously there's foam going around, you can squish them, and there are pockets of gas in there. These are like cell walls. After researching that, I decided to just move on into researching some different foams that are on the market, and I happened to stumble upon open-celled versus closed-cell foams. And I was like, well, what is this? So I figured it out. I defined open-cell foams as pockets of air within the foam that are caused from gas bubbles in the production process being released into the atmosphere. So think of memory foam when you think of open-cell foam. Very soft, very pliable. If you squish it down, it squishes down a lot, and it bounces back up right immediately. But the key takeaway, people, is that it cannot resist water. If you get water on it, it will absorb it. So like a sponge almost. And this is going to be a really key factor into the research that I go like in the future, because closed cell foams are the opposite. They do resist water. And I define them as internal cells that sit closely together with their walls closed off to the outside, in like the outside world, basically. So they can resist water, which means if you spill water on it, it'll just like kind of slide away, which is great because you don't want your foam roller to mold. That's really nasty. No one wants that. If you don't understand what I'm saying, I'm gonna explain it a little differently. Think of it like plant cell walls. These walls can open up like gates almost and let water in. And that would be an example of open cell foams. And closed cell foams is an example of this gates or these walls staying rigid and closed to the water. So really important, and it really guided my research moving forward. Next slide. If you were here last time, you may have noticed an additional foam that's on the list now. If you weren't here last time, no worries. I was able to narrow down, because of the information I found about closed cell foams, to these 4 foams. They all have pros and cons, and they have to be valued and that's how they have to be valued. There are pros and there are cons. For polypropylene foam, it's very flexible, it's very compressible, it's lightweight, and it's resilient. All great things in a foam roller. Some limitations, though, is high temperature applications and resistance to UV. This could be good in some uses and bad in others. For foam rollers, doesn't seem to be that much of an impact, I would say. Expanded polypropylene foam, some pros are it reforms to its original shape after impact, it's durable, it has cushioning qualities. But some cons is its resistance to compression and impact, which has led me to be like, it's a good foam that I found at the time, but probably won't be used in this project, because the whole key is compression. After that, I researched polyethylene foam. It's very flexible, it's durable, shock absorption, and impervious to most chemicals. So, like oil that you have on your hands, it won't absorb that. Same with most other closed cell foams, which are all of these. But some limitations, obviously, is that it's tough and also it's limited in high temperature situations. So I wouldn't suggest putting it near the heater. It would probably melt. The last one I found, which was new, thanks to All-Star, is ethylene vinyl acetate foam, which is also known as EVA foam. It's very flexible, it quickly recovers from compression, it's lightweight, it's shock, impact, and vibration absorption properties, and it's very malleable. This would be perfect, but there's some downsides. It's flammable and scratchable, and can be described sometimes as having a very odor, which not everyone wants with their foam roller. Some other stuff I found was I researched all their chemical, like all their chemical formulas and like how they're made. Unfortunately, for whatever reason, it's not showing up, but this is an N and this is an M. The N stands for the degree of polymerization in the process of the chemical formulas, and the M stands for molarization. For PPP foam or polypropylene foam, sorry about that. It is the polymerization of propene monomers into three different other polypropylene polymers. Acetate, isostatic, and then cytotactic. Yes. And then all those can be used for different uses in foam industries. So one might be better for packaging and one might be better for on the water side because it's buoyancy. EPP foam or expanded polypropylene. It is made up of polypropylene beads that are injected into these molds, and with the help of pressure, steam, and heat, they all fuse together to create EPP. Ethafoam is the third one that we saw on the other list, which is polyethylene foam. It is a polymer that's formed from ethylene that is heated to its melting point, and then we put in a glowing agent, which basically causes it to expand and create the closed cells within the mold. So, very interesting. And then EVA foam, as I said earlier, it is ethylene, it's vinyl, and acetate that is worked together into like this big like blender for dough almost. That's what it looks like. And it's made into like, it looks and feels like dough texture. That can either be made into sheets, so there's like a big rolling pin almost kind of machine, or into these little pellets that are then injected into a mold and compressed into whatever shape or thing you want. And then I have one fact for you guys, because I also found the history of foam, and that is foam dates back as far as 500 BC to the Mayans and Aztecs, and it was originally created from the sap of rubber trees. So that is your fact of the day. And that's it.
So a big part of what we're talking about is that it has to do something with manufacturing. That was one of our big pieces here with this project. They had to have some kind of piece with STEM and with manufacturing. So two of our other proposals that we had did have that with manufacturing. And so well, one of them was to try to make a magnetic door locker for the bathroom, because sometimes the locks don't work properly. So that was an interesting piece on that. As you can see what Isabel has done so far, and Abigail as well, they really went to define what this whole project was about as far as the background to it, right? And so you could definitely see a lot of the science and a lot of the engineering piece and a lot of the technological processes that the manufacturing were pointed out. So as we keep going, I'll put in more things as we go through. So the deliverable that we had to have at the end of the project could either be a product, it could be a system, it could be a proposal of some sort. Our proposal here, as you can see, trying to make the foam roller be more user-friendly for student athletes to compact, to put it in their gym bag, and then they could go to take it out on the athletic fields to try to reduce injury. And that's where Mr. Diffin came in with quite a lot of help on this. As our athletic trainer, as well as a biology teacher, he talked to the students back in March about this, just fact about the foam. So, let's keep going. Foam roll.
So, beyond just the chemical properties of foam rollers, we also want to look at the physical properties that other companies use in their foam rollers, even though they might not be collapsible ones. So typically, there are three main factors that people look for when they're buying a foam roller: the size of it, the style or the texture of it, and the density of the foam. Typically, the three sizes you get is you'll have large foam rollers, which are 36 inches, the ones going around right now. These sizes of foam rollers are better for back massages, as they just span that length. They're typically also harder to carry around with you when you're going to travel. They cost more money to produce as they require more material, and they take up more foam, and therefore it's more for us to compress. So when we're deciding on what type of foam roller we want to make, we might want to shy away from this. Medium foam rollers are typically 18 to 24 inches. These are better for more targeted massages or rolling on extremities. They're better for more confined spaces and are slightly easier to bring around when you're traveling. They still cost, though, pretty high amounts of money to produce. They still have quite a bit of foam in them, and therefore are still a lot to compress. And that leads us to smaller foam rollers between 4 and 12 inches. These are good for targeting specific areas of the body, like your arms, your calves. These require the least amount of material and money to produce out of all these, and therefore they're probably a better one for our product. Style in texture or smooth foam rollers is another big thing. So smoother foam rollers deliver less pressure, they have more even pressure distribution, and are good for beginners, whereas textured foam rollers are for more precise targeting, deeper massages. They get into those hard to reach areas, and more people that have experienced foam rolling are more likely to use them. So when we're deciding on who's gonna need to bring a foam roller that collapses, if you're somebody that uses foam rollers all the time, that would be something that you would be willing to invest in. And therefore, a more textured foam roller will appeal to those people. Densities of foam, as we've talked about before, if a foam is very dense, it brings that extra pressure. If it's too soft, it can be unsatisfying. It doesn't really deliver what you're looking for when you're trying to get that nice deep massage. Some companies, if they have foam rollers of varying densities, they will color code their foam rollers aligning to those densities. So lighter colors like white and light blue are typically for softer foams. Medium colors like reds and oranges are better for medium density foams, and then the darker colors or black foam rollers, as you'll see here, are the densest foams that companies will offer.
So before we get into the other foam rollers on the market, we decided to do a strategy canvas. So that's an analysis of the market and all the different other products. So there are only 3 other compressible foam rollers on the market, and one is basically just a cheap knockoff of one of the other ones. So why do we do a strategy canvas? It's to figure out where our product can succeed. So we all rated all of the other products on the market and then put it all on a graph so everyone can see. So we want to focus here where the size compressed, all of our other products on the market seemed to not do so well. That's where we want to succeed and make our compressible foam roller smaller and more manageable to carry around. There's some variation, but mostly in comfort. There's a decrease here, so we want to try and make our foam roller a bit more comfortable than the other products on the market. And our cost differences are great. So the best foam roller on the market, as Devin will go into more detail about in a second, is very expensive, and the cheaper ones don't have as much comfort. So we want to try and find that balance between the two and try and succeed where other companies have not done so well.
And there's a great application of this too in engineering. They do a different product, or they're trying to do an innovative product, or to develop one from the very beginning. It's an invention. Talking about these different aspects. Some of it might be cost, some of it might be the density, the durability of it perhaps, or the adaptability to do other things with the product. So this is a great example that the students put together here on this. I just want to add that in.
So on the market, there are only 3 collapsible, and I say collapsible, but really I just mean any type of foam roller that changes its size on the market. There's the Brazen Life Morph foam roller, which I'll go into greater detail in a second, but that foam roller has a plastic framing and a denser foam, which is recycled foam materials for the actual foam part or the exterior. The Shadow Fit and Get Lean collapsible collapsible foam rollers, really they spin together and more so compressed than they do collapse. So that's just as compressed as you're going to get, whereas this one just collapses flat. On the Brazen Life website, they advertise that it's about the same size compressed here as like two folded shirts put into your backpack, whereas this one is still pretty heavy to carry around. Also, the Shadowfit and Gatling foam rollers have no foam on them whatsoever. They're completely made out of plastic, and therefore they're slipperier than this foam roller, as well as a lot less comfortable to use. Through looking at these and realizing these are the only 3 or really 2 foam roller designs on the market, we realized that there's very few available, but foam rollers are used all the time by a bunch of different people, and therefore there's a huge demand. And they're so inconvenient to carry around with you that the demand for a product like a collapsible foam roller, or one that is easier to transport with or better for student athletes or whoever may use it, is in huge demand, but there aren't many people out there delivering.
One of the things we talked about, we went to All-Star, was the Vice President of Product Development, Mr. Yurga. He was telling us that NCAA is a huge area that would love to have these types of products. One such person that he has that endorses products, Paige Halstead. She used to be the catcher for UCLA. And she actually endorses a lot of the All-Star products. So you might see that Jason Varitek, he played for the Red Sox. He had a big All-Star emblem on his chest protector. So the foam that's involved with that, he really helped us out a lot with this piece. And saying about NCAA. So I followed up with this person. Her name is Felicia Martin. She's the NCAA Senior Vice President of Inclusion, Education, and Community Engagement. And so I'm going to call her after our program here today, perhaps tomorrow, and tell her what we're trying to do and what we're trying to possibly have on the market, and see if they have any interest in this. Of course, our governor, the former governor, Charlie Baker, he's the president now of the NCAA. So maybe that might be an inroad. Again, there's politics and everything, and I tell the students, the networking piece. So maybe he might, see how we're from Massachusetts, the Massachusetts high school, he might be able to help us with that too. So, anyway, I just want to interject on that.
So the history of the company Brazen Life, for the people that make the More foam roller, is pretty interesting. They're actually the first company to make a collapsible foam roller, and the inventor, Nate Laurie, he is an ex-NFL player who played for 8 years of professional football. During his career, he suffered a back injury, and then during the time that he was recovering from that injury, he did like physical therapy and used foam rollers all of the time, and as he did and continued to after he was finished healing. While using foam rollers all the time and kind of depending on them, he realized that they're just so incredibly inconvenient to bring around with you, and he decided to solve the problem by making a collapsible foam roller. In 2015, he founded the company Brazen Life, and in 2017, with his business partner, Tom Hopkins, up here on Shark Tank. On the show, they were met by 80% investor interest for their product. They ended up shaking a deal with investors Lori Greiner and Sarah Blakely for $250,000 in change for 20% of their company. You can see over here them on the show, and then this is a picture of their product.
A little bit later in our program that we have here today, Mr. McKenna, he did a lot of work with accounting. He can show about the accounting piece on this. We have talked a lot about the numbers and about the percentages, this, that, and the other. There's a lot of accounting that goes into this. There's a lot of different pathways of careers that go into a product.
So the dimensions and design of their foam roller, they actually have a patent for, which I believe was filed in 2015 to 2017, sometime in between there. Their dimensions for their foam roller, it's like 14.5 inches long, 5.5 inches tall, and then it collapses down to about 2 inches, which is where the 2 folded shirts come in. It weighs about 1.5 pounds and supports over 350 pounds of weight. This is the design that they have posted on the website. So essentially, this is wood within the foam, and these strings here, or these rings, they're on either side of the foam, so when you pull it, these, I don't know if you can really see it, but these rings here actually will just collapse downwards, and then that's how the roller is able to flatten out. And then when you pull it out, these come back in, they kind of lock in place here, and then it just stays in its form when it's a full cylinder. Looking at these foam rollers and this particular design, we realized that the comfortability and it's just a lot easier to have things like this. And this smaller scale is pretty much what is typical of most foam rollers, as well as what we were looking at for our foam roller based on what was preferred by customers on the market. We looked at this design in particular, thought about different ways that we can improve upon it, which we might talk a little bit about in the design section of this. But the basic design is a really good thing to base off of, but we wanted to improve upon the compressibility of it. So yeah.
This is the Crestline concept. This is based off of the folding design. Kind of works like counterclockwise. This was a simple prototype structure that I made in using the CAD system known as Onshape. And this is based kind of off of this, where it had the triangular panels and such. The compressibility of it works by rotating the structure counter to each face, rotating in on itself and compressing down to something simple like this. This structure is incredibly strong on the sides of it, being resisting compression from the on the joints, which are very strong. But the main trickiness with this design is how would this be manufactured in a machine? This would either require some specialization, either some specialized equipment, or something else entirely. And it was ultimately not developed further beyond this simple CAD mock-up. So we moved on from that. We started exploring the various other locking designs, kind of like how Brazen Life did theirs with these kinds of locking discs and such. This was a design that I had explored, where it kind of used a gear and shaft system, where where a person would basically twist it, and they would push on the walls of the foam, expanding it out. This has a bit of, though we discovered there might be some more complications with this, as foam is more compressible than it is stretchable.
So in this part right here is talking about the engineering process, the engineering design process in particular, looking at going to develop some different ways to solve the problem. So obviously they're trying to make the product be more user-friendly, to see now to collapse into the gym bag. There's one way of doing that, to get the locking mechanism in there, and there are 3 different ways to have that done. So they're trying to brainstorm here about what way would be the best way of doing it, and they use the origami piece, which you have on your desk there, I believe. It is well made. We have those. We have the locking mechanism here with the gears. So they're trying to fold it down by using gears. We've sort of continued further exploring prototypes such as an expandable shaft mechanism and compressibility.
Okay.
Oh, wait a minute.
Back up.
Yeah, 1 second.
Back up.
So basically, I would say think of an umbrella, and you push the buttons and all these different rods come out of it and to expand and make your umbrella thing. those rods that like each slide in and fit with each other, that was the basic ideas for this. So like each hole would be a different size and like where the rods would go, and so you would just basically be able to smush it that way, and then it'll go boop, and it'll compress.
Kind of like a lightsaber.
Yeah.
Oh, yeah, like a lightsaber.
Extendable lightsabers that people used to play with
I think of like
when they were kids.
You flick it down, they all come out because they all fit inside of each other. Same concept with this, and that way it would be able to compress.
Each of these segments would probably each of the foam segments would probably would fold down and into is kind of the shaft.
That was one of the concepts, and then the other one was to have this like shell casing over it, and then those shell casings would also fold into each other, and the foam would fold that way, and would almost mimic a roly-poly, which Abby has been researching a bit.
Yeah, I've been looking into different rolling animals and how their scales function, and trying to take ideas from nature and implement those into our designs as well.
In engineering, they call that the biomimicry piece, right? Trying to emulate nature with something that's in engineering. So the biomimicry.
Overall, with this entire collapsible foam rolling piece, is that you're discovering that this is why there has been like so little, why there's only been like 3 main competitors in this type of design is because it is very complicated, and we are dealing with something that's very tricky to work with. However, we do have very high confidence in making this work and discovering a solution to this problem.
A huge part of this problem that we've been finding is that when you look at what people want out of a foam roller, they want dense. They want something that's going to actually be effective. But if you have a dense foam, your foam's not going to compress very hard. But if we're trying to make something that compresses, it contradicts itself. It's really hard to figure out how to make something fit inside of itself or expand when the thing that we're trying to make is the complete opposite of that.
And I found a lot of difficulty with foam is that it's different in real life than what I can list off properties to you about the foams. They behave differently when you actually have them in your hands than what you thought they behave like according to their properties list.
Yeah.
Like some of the foam that we saw at All-Star, they use different foam for the inside of the helmets than they may use for the chest protectors. All depends on what the property is that they're trying to use in the application that they need it for, right? So it all depends on what they're using it for. One of the things they talked about there is when they talk about paint, this is a very simple thing that they had. I don't know if you're going to get into this or not, but one part that stood out for me when we went there, to me, was the baseballs that they had already hit the mask. They found a chipped off paint, and it's like, this can't happen. You can't have paint or chip off the spray paint on the face mask of the helmets. And it just came out to a simple thing that it wasn't heated with water. So a whole bunch, so they were going to get rid of all this batch and get rid of it, waste all this product. And they said, why don't we just take the masks off, bring them to our house, and go to cook them in our own oven for about 25 more minutes more at about 500 degrees Fahrenheit. So lo and behold, the next day they came back and they found out that they were actually impact testing it, and the paint did not go chip off. So they saved all that money that would have been lost with that product. So they said, what did they say, about 525 masks that they were able to save. So just a simple thing of that was interesting, and that's what they're saying, is that it's very difficult to try to get one thing and then at the expense of another, and then try to get that property and that property to work. So it was quite interesting for the students to see. All right.
So speaking of properties, one of the things that we looked at was the ASTM standards, which stands for American Society for Testing of Materials. Now, the ASTM looks at the different materials of different products or different materials to see what classifies something as a specific thing. So what classifies this foam separate from this foam? Or how do we make sure that this foam tests well enough so it is safe for its intended purpose? So when we were looking at our foams, we realized that the most common ASTM that was used was D3575, and it is the accepted industry standard for all testing of properties of foams or any closed cell cushioning materials that contain or are olefin polymers and polyethylene foam, which is one of the ones that we were looking at just plain. This ASTM includes 13 property tests, including compression set under constant deflection, compression deflection, tear resistance, water absorption, as we've talked about, flammability, ease of ignition, energy absorption, thermal stability, tensile strength and elongation, thermal conductivity, density, buoyancy, constant compression creep, and dynamic cushioning. So when I'm looking at the ASTM standards for the different foams, 4 main ones come to mind, and that's compression strength, which essentially is just how much can you apply pressure to something before, or pretty much just how much pressure can this thing take. So when we're looking at our foams, that also plays into density, so how dense something might be will attribute to how much compression it can take. Cell size only really comes into play if you're using something that is open-celled, but if something is open-celled, looking at how big those cells are does mean something. It does play a difference in whether or not we even consider it or not. It also keeps in mind how soft something might be, how dense it is. Water absorption comes into play when we're thinking about like absorption of sweat. And possible densities, we've looked at different foams have their own densities that they just inherently are, but also you can get a specific type of foam in different densities. Like when we went to visit All-Star, we realized that they had all EVA foam, but they would have different densities of EVA foam.
These are all different.
Yes, but I believe they all are the same type of foam, but different densities of such.
And the big thing too is that mass per unit volume, so that's what you're looking at with density, right? And so it may be a larger piece, but the density might be smaller, or it might be a smaller piece and the density that might be larger. So it all depends on what you're talking about. So it's a very important piece that we gotta get. Sorry.
Also, depending on where you get your charts from or whoever tested the material, they can have certain things and certain tests that they were supposed to do according to that ASTM, but they might test different ASTM standards aside from just D3575. So different companies or whoever tested it can have different. They might test for the same things, but it could be in different units. It could be some part of this ASTM, but then some part of a different one. They don't necessarily all use the exact same thing, which makes it difficult when we're looking at it to compare because they're not all in the same unit or have all the same things to compare. Aside from the fact that you can also get them in the different densities for the different material or for the same material. So you're looking at the different densities for each type of foam, the different units that they might be in to represent the same thing. There's a ton of factors that come into just comparing two simple foams where you can look at it and you can feel it, but looking at it and feeling it is much different than actually looking at its inherent properties.
You can see the different ones here. There's tensile strength. On the screen I can see it. Well, you mentioned the buoyancy, thermal conductivity, water absorption, like you mentioned. How is it going to be working with flames, so that you get the flammability of it, and the resistance to chemicals. So there's all different types of test standards on this with the ASTM.
So it's a little difficult to see. This is what like a typical ASTM standard chart might look like, but you'll have the different category of what's being tested, but then you'll also have the different whatever testing they were using. So like this is ASTM D3575, but then this is ASTM C177. So different test standards might have the same thing that they're looking for, but you're not going to get them for the same thing.
And they use the pounds per square inch. So if this is going international, they have to do pounds per square millimeter, pounds per square, say, centimeter or something like that. We'll go next slide.
Yes. So then we go back into All-Star, and you have testing of the individual properties or the different materials that might go into a product, but you also have the testing of the product itself. So when we were at All-Star, we were able to tour their just testing room. They mostly had impact testing stuff in here. So they were testing their helmets in this room. So they had like a head, and then they put their helmets on the head. And then they would use like air pressure to shoot at the head or the helmet to see like what damage it might take. But then and that would simulate like a baseball being thrown at the helmet. And then what we're showing there, it's kind of hard to see, but they would put the head on pretty much this mechanism that would just fall straight down onto this like hump. And that was supposed to simulate like a baseball bat being hit in the side of the head with a baseball bat. But then they also had another one to simulate it more accurately, where they would put the head stationary and then they'd swing a bat at it instead of having the head fall on the bat. So you have to test not just the properties, but also the actual product itself. So it's an extra piece that we have not yet gotten to because we have not yet have our physical product with us, but it's something that we, visiting other places and seeing their facilities, makes us like realize all the different other aspects that go into it beyond just the research.
So companies, that's good. So we researched a lot of different companies. 4 main ones that we found were All-Star. Again, we went and toured their company a few weeks ago, and it was a great experience. And yeah, Mr. Yurga was he's the one who showed us around, and yeah, and we saw tons of the testing facilities, including the just where they like keep all their storage and stuff. And so that was cool. We also got Rogers. They research, or they specialize in like a wide variety of foam applications. So they take a variety of different foams, and then we got Mogiform, and we reached out to them a week or 2 ago, asking if we could tour their company as well, and they said yes. So we're looking to do that June 12th, and they are focused in like the furniture aspect of foam, and they even do the woodworking and the springs in them too. And then we got Foam Tech, and they are located in Fitchburg, and they specialize in foam packaging.
Big piece on this is mass hires. Mr. Wilson just came in. I just wanted to recognize him. He is instrumental in this and getting a lot of the companies to the high schools. So the whole idea is that working with the high schools, he's able to get us to be networked with these companies, so that the students can have that connection to the real world, from school to the real world and into business. They can see their academics being put into reality. So there's application from the theory. Okay? And the whole thing is that with these businesses in here, this is one part of the pathway, the engineering pathway, right? You have other ones too. There's business, marketing, and finance. You have agriculture, and natural resources. You have humanities piece as well in there. You also have health and community services. So you have a lot of pathways from this. Ours is engineering because it's a STEM internship. But the idea is that any internship that the students could take this form, right? This right here is very in-depth. As I said, we started this back in February, right before the February break. And most schools, they start earlier than that. This is the first time that we've had it here at Indiana Shirley. We hope to have it more next year. Now that this is the pilot year, hopefully the next year we have some students that are returning from our program so that they can be the spokespeople for us, right? And so to build it even more and more. One of the things that Mr. Yurga said at All-Star was that he was very excited to have this. In fact, any of the businesses that I've contacted, they're always helpful to the schools because they know that the economic engine are the students and is the students. So they know that having students being able to be exposed to things in these different aspects while they're in high school, that can help their businesses out, and that's why they do that. A lot of students may work there part-time as they're going to school. A lot of students may work there full-time after high school. A lot of students may work there full-time after going to school and getting that 4-year degree. So it gives a lot of options to students. And like I said, the module form would hopefully can go there on June 12th. We're waiting to hear back from the representative there. But it looks pretty good that we're able to do that. This program itself has to be done by the 30th of June, which is the end of the fiscal year for Mass Hire. But we're going to try to get it done by the 25th of June. The students will be done with it by the 17th, around there. So we still have more to do on this, but as you can see, they've done a great job with this part, and we're just probably about 92% done right now. And I say that because all we got to do is just go to compile things and go to put together a final copy of what we've done. So something, a deliverable can be here at the high school, can be at Mass Hire, and it can also be here for the students to take with them. So what a wonderful thing that they can take in their portfolio when they go to college, or they go into the world of work, or they go into the world of business, right? They can take their work with them, a portfolio, these slides and this packet here explaining what they going to contribute to it. So they can see the team is working together, from the design to the theory, to the piece about how the ergonomics of it work, how we went through and decided what to do for a project, and the brainstorming involved. So students, do you have any final thoughts?
There's another slide.
Okay, go on. Yeah, no problem.
Yeah, so for takeaways when we toured the company, so we found out, it'd be nice if we found somebody who was specialized in, training, athletic training or sports medicine, so we could dive into that aspect of it, see what we're missing, and then the date code / safe product in case of legal issues.
Okay, so the date code and safe product, in case of legal issues, is basically like once a month we'll take a product and we'll just be like, okay, so this was made in, let's say, August of 2024. Let's say we were to have a legal problem in around June of next year, and they were like, oh, our product was made in August. So we could go back to that test subject from August, pull it out, and do a ton of tests of the exact things that caused these people to be like, hey, we're going to sue you. And then we can be like, hey, this actually is very unlikely to happen, so can you please drop charges or something? I don't know. After that, I took notes. So after that, we were told to ensure proper orientation for time efficiency for 3D printing. So basically, if we were to 3D print something, we want to make sure that it's oriented on the 3D printer the correct way, so it can save time as much as possible. So instead of making a 6-hour project, we can narrow it down to 3 or 4 hours. Another thing is add 3 standard deviations to graph points when we're testing. So if we were to get a data point after testing a product, bless you, we want to add 3 standard deviation points, and then we can definitely say, okay, this is like all the amount of range for this data that we can get. If it were to exceed this, it's really, really, really unlikely to ensure the safety of customers when buying the product. To remove as many variables in testing as possible for testing. So we want to make sure that it's as controlled environment as possible to ensure that there are no outside factors contributing to how the foam rollers get affected in the testing field. Testing and feedback is best, so we're going to hopefully after we have our finished product, we're going to hand it out to a ton of athletes, and like either professionals, student athletes, get a whole range of people, have them test out the product, and then fill out a questionnaire saying, okay, this is what we liked about this product, what would you change about this product, what more can we do about this product, would you buy this product, ton of different stuff, get feedback on it, and then modify our design so that it's constantly changing and appeasing as many people as possible. For testing, with both just sitting in weather and elements and experimentation, we want to make sure that our product will do the best. So if it were to melt in the sun, we'll be like, okay, let's not use these products. Let's try this plastic instead, or this foam instead. So we want to keep changing and looking at all the different factors that contribute to our final product, ensuring that it does the best that it can.
And the big thing he was talking about too was the math involved. So talking about the use of calculus and this, taking the area under a curve, right? All these types of things, integral functions and all that. It was just an amazing trip there, and like Abigail said, some copious notes that she took down that you can see, talking a lot about experimenting and a lot about the elements, right? And big takeaway too was constantly improving your product all the time, constantly improving, because you got competition. With competition, you have global economy competition, and you have to make a better product than somebody else does. So that's why they try to stay up on the edge of the industry.
Okay, here's Mogiform, the next company we're hoping to be able to tour and reach out to. So they're located in Fitchburg, again, when we asked to go to these companies and reach out to them, we are asking for like advice on what we can do with our product to see what we can do better with it. They specialize in furniture, right? And they have furniture in different spaces such as group homes, libraries, schools, and juvenile centers. Our goal is to see what other companies accomplish through their development strategies, get a head start on the development of our product, find ways for us to improve on the current development of our product, and learn the process for testing products. Going to these companies and seeing what they do to make their product, it can help us, and it's a great starting point, but a lot of what we do developing the product is just, we have to learn from experience. But it is, again, a great way to understand what we need to do and what we need to implement into our product.
So our future plans for this product is the production. So hopefully we'll be able to be standing here someday holding this foam roller, or be passing around this foam roller to different people who are athletes, or people will start buying this product because they're like, oh, I need to carry foam rollers better. This is a great option. After that, we're going to do testing to make sure that it's in like an all set, make sure that it can stand up to the weight of people putting their bodies on it and rolling, and a ton of other potential factors that might go into the different environments that the foam roller will be in. And then continuous modification, which I said earlier, which is basically just we're gonna read reviews, or we're gonna have people fill out questionnaires at the very beginning to see what we can adjust, or what we can keep, what we should change, what should stay, stuff like that. So in conclusion, the foam rolling is beneficial for relieving pain in your body under concentrated amounts.
There are many different foam options, but we need a closed-celled one. So nothing grows in your product. You don't want your sweat turning into a plant.
How the foam will fold and affect the design.
Things to consider include foam folding, our name of our company, or a logo. Colors, we want to associate a color with our brand, and prices. And
companies, we also want to see what different companies would be willing to produce our product.
And then just taking in feedback from everyone else.
And a big piece would be maybe we could contact the MIAA, that they govern all the athletics here in the state, for high school competition. We look at that. Also the NCAA, and again, like I said, the former governor is now the president of the NCAA, so hopefully that will help us with that. So we have a lot of good refreshments still here. Thanks to Ms. Keisha. Thank you very much for getting everything organized for us. We appreciate that, and thanks for that. Do you guys have any final thoughts you'd like to say to the audience?
Actually, if you want to go down one more slide.
One more slide, okay. Thanks.
So thank you to Mr. Tully for leading us along this project. Thank you for Mr. Dixon for coming into some of our meetings and helping with some questions that I had about my research. Thank you to Mr. Wilson for joining us on this adventure. It was very appreciated. Thank you for All-Star and any other outside resources for giving us feedback, giving us advice, and helping us along this journey. And if anyone has any questions, comments, concerns, or any ideas that they want to bring to us, now's your chance.
And thanks to the steering committee too, as well as APAC and the parents for being here. We really appreciate that. The steering committee, like I said, hopefully working to have more opportunities and activities for the students here at the high school. And hopefully we can bring it down to middle school, so that would be a feeder program to come to the high school. Now, Mr. McKenna, did you want to put something in on the county?
Sure. Nobody wants to talk about money. and I don't think I could be 1/10 as eloquent as these guys. But here's the deal. I'm not really talking about the money. I'm talking about job opportunities. Okay? When I was a younger man, I was a finance manager. And one of the things I learned is accounting literacy is super important. Okay? And, you know, if these guys are putting this together, they're going to need to put the finances together. And you know, the other thing is, when they're in school next year, a lot of these guys are business-oriented. You're going to be in Accounting 1, or you're going to be in Intro to Business, very common first-year college things. So, you know, as we go forward with this, as we prepare graduates to get out of here, we want them to have those skills. One of the main skills is, I would like it if kids not only knew the basic financials, profit and loss statements, balance sheets, but also how to do the various the various jobs. And use especially Google Sheets and Microsoft Excel, I should say, or they're basically the same thing. That's a skill that ought to be taught here. It's, you know, kind of, like I said, marketable job skills. And that's not only just for, college-bound kids. You've also got kids that are going to wind up in the job force. When I was a finance manager, there were, I had accounts receivable clerks, I had AP people, I had payroll people. You know, those are all jobs that don't necessarily require a degree, or they may require an associate's degree. Those are transferable skills, you know, without college, that they can get jobs in. I'm talking to Mass Hire here. So that's really my push. I want to make sure that, you know, as we build financial literacy through this program, okay, and make sure you guys are making a profit and doing all the right things and hiring the right people to get the job done. You know, this is a call for for learning finance, skills you're going to need in college, skills you're going to need in life. So that's all I had to say about it.
Thank you. We put in some time for you for 15 minutes. We do want to end at 4, but we figure open up to the panel and everybody else here if they wanted to ask some items of the students. Again, there's plenty of refreshments over there.
Any questions?
Any questions?
I just have a few comments. Not necessarily questions, but so very well done. I was very impressed by the courage to get up there and present. Very confident, very mature. I've seen CEOs, senior people, engineering directors, etc. struggle to get up and present in front of an audience like this. So kudos to you, very well done. Just a couple of comments. Maybe I missed it, and if I did, I apologize. But I would suggest that you assume your audience knows nothing about the product or the application, right? So maybe you can open with some videos, maybe show an improper use of a foam roller, maybe a proper use, and have some fun with it. Maybe you can make a video, put one of those big foam rollers on somebody's back and have them lumbering around. Like I said, have fun with it, and then dive into the ideation process. It was a little bit confusing to me how you arrived at those 4 different ideas, and then how you only came up with 4 ideas. I would have assumed that you would have a bigger list of items, and how you focused in on the foam roller. But thank you, very, very nicely done, and congratulations.
Thank you.
Just a quick comment, Anthony Wilson from Mass Hire. I just want to say that any caregiver or educator that's been involved in, this whole process and the learning of you and educating you, they should be super proud. This is a phenomenal team. I work with several other high schools in the region, and this is so thorough. You have done such a great job. All the details that you put into it, from the design to the research to the outreach to the marketing, really a phenomenal job. This is exemplary, and I hope hopefully other people will be able to see and hear about the great work that you've done. Mr. Telly's been able to put together an A team, just a dream team right here, and I'm encouraged, I'm enthused, and I know that our futures are going to be in good hands, and because of foam rollers, maybe our back will be in good hands too. So just want to say that as an outsider observing this, you've done a phenomenal job, and you should all be very proud of yourselves, and you've shown maturity far beyond your years. So I look forward to great things coming from you. So thanks for allowing me to observe.
Thank you.
Thank you.
Thank you.
Well said.
Any other questions, comments?
Hi. So Miles, I heard you asking your dad about patents
Yeah.
the other day. Is this why?
Yeah. So I guess I asked a lot of questions. It's quite confusing, but basically, if we were to want to patent this idea, or if we want, it's for our company, or if we want to sell the idea to let another company use this and create the product, I would get my dad to patent it for us.
You should get
For free,
the credit.
so.
You should get the credit.
And your dad's a patent lawyer, right?
Yeah, and you do it for free, which is nice.
You should have had us sign a non-disclosure before you presented it.
Yeah, I talked with him about that, and
Yeah.
Well, thankfully, our design isn't finalized, so you can't steal it.
not necessarily.
Or maybe, I guess you could technically, but you don't know what it actually is yet.
And it's on camera.
Oh yeah, it's just been broadcasted.
Oh! Right.
Oops.
Oops.
I mean, not much oops.
Okay, I forgot.
Twice.
Don't steal it. That'd be great. Thank you.
Well, you haven't given away the idea. You just
design.
explained how you engineer, or how you came up with narrowing down the idea. So you're still safe.
Even then, if we did want to patent it, we'd have to patent it within a year of disclosing it to the public, and but it would only be patented within the U.S. It wouldn't be protected internationally. So
Because we didn't broadcast it.
yeah, but
Anything else?
What do you think, 10% in the finance for 250,000?
I just want to say that I enjoyed working with students. They were great to work with. Always here and willing to work hard. We met online too as well through the Google Meet that we have in our Google Classroom. We developed that, so we have that going. Just looking forward to the final product, which will be our the document we're going to give it to Mass Hire. And in that, we'll also include those other ideas that we had as a proposal. One of them was more of a career development piece, We're going to be the reverse college day and so on, the trades day, that 1 weeks, and do that more. Another one was trying to do something more environmental with soil and so on. We wanted to do that with agriculture. And then we had that magnetic block piece that I mentioned with that. And then this one here was more towards what Mass High was looking for the manufacturing piece and this with different companies and industries around us. So there's that piece. I do have one thing next year that we already have started already is the compost program. I think there's a compost program they're doing. And so maybe we could draw on that. That's some folks were doing this year as a civics project that they didn't get a chance to do yet. So I do have the easel on the back on it. But we'll take a look at other ones too next year, other projects. All right. Feel free to join us. We have some food over there on the side, and we have some other.
One last thing. And we do have funding opportunities for summer STEM stuff. So you've probably seen the flyers around this little nook area. And also, if you have any questions, Mr. Tully can give you my contact. So we have several opportunities available for summer. So, same pay.
Same here.
Another 100 hours.
You don't get the course credit, so we also have 2.5 course credits to students to get for this as well as up to the 20 hours of the community service hours. Excellent. We have that. I negotiate that. You'll get community service hours. Anyway. All right. Thank you very much for coming, everybody.
Thank you.